So I did a diagram. So I did like a dot for particle P,
Mm-hmm.
and then I did 40 to the right and 10 to the left, and put 5 kg above it.
Okay. Right. Let me see. So there's also particle Q, and that's connected. So this one is 5 kilos of mass of 5g. Sorry, mass of 5 kilos.
Yep.
This one is 3. And particle P is pulled.
So we'd have 16 n to the left.
Well, this one has. I'll just do it like that. So this one has 10 to the left, and this one has 6 to the left.
Okay.
And so you have to figure out the acceleration of the particles. And you
So we'd
do.
use F equals ma.
Yep.
Okay. So force. So would force be 40 and 6 and 10?
Yep.
So would you do 40 minus 10 minus 6,
Mm-hmm.
which gives you 24. So 24 equals m, which is mass. So you do both masses, which is 8g.
Just 8.
8 and then a. And then you divide by 8 on both sides,
Yep.
which is 3. Its acceleration is 3.
Yep. B.
So first, would you still need to use F equals ma?
You could, yeah.
Okay. So would you need the acceleration you got before as a?
Mm-hmm.
Okay. And then would you do 8g for F, g for F?
So the trick now is to find the tension in the string. You would just isolate the particles. So you would say either just looking at Q with the tension going away from Q, or looking at the particle P with the tension going away from P.
Okay. So you'd have 40 minus 10, which is 30.
Yeah.
So F equals 30.
Mm-hmm.
30 equals mass, which is, so it'd be 5.
No, sorry. It's 40 minus 10 minus T. So 30 minus
yeah.
T. Yeah.
So 40 minus 10 minus t equals 5a, or 5 times a.
And what's A?
That would be 50.
Yep.
Oh no, a is 3, sorry.
Yeah, sorry. Yeah. I thought 15, wasn't it?
Yeah, 5 times 3 is 50.
Okay.
Then it becomes 30 minus t equals 15. Then you add 30 to both sides. The tension is 45. No, you minus 30 both sides, sorry.
Okay.
And then you'd get minus 15. Then you times both sides by minus 1, which would give you 15.
That's it. So tension is 15 newtons. And any idea about part C?
Is it that it's not elastic? It's not like stretchable.
The consequence of that is the acceleration will be the same throughout the system.
Okay.
So like the acceleration of P will be the same as the acceleration of Q.
Yeah.
If the string was to stretch like it might in real life, P would go a bit faster than Q. What else? Also, tension is the same throughout.
Okay.
So maybe in real life the tension will be different at different points on the string. It might break at some point, but not. Let's just see. Well, let me just see. Whole system, A is 3, tension is 15, and then inextensible, the acceleration of the masses is the same, and then light, tension is the same throughout the length of the string, and the mass of the string is negligible. Okay, I didn't notice the light. Yeah, so we didn't add any mass for the string.
Okay.
Try doing the same as part B, but with particle Q.
Okay. So first we'd do, would it be 40 again? 40 minus 6?
No, just the forces acting on Q only.
So there's no forward force?
You have tension moving away from it.
So it'd be 15.
How do you
minus 6.
So like T minus 6. And let's see if you get 15 again.
Equals 3 times 3, which is 9. T minus 6 equals 9. And then you add 6 to both sides, which gives you 15. So T is 15.
Yeah. And so it should be, that's how it'll work out.
Yeah.
Okay. Let's give this a go. Yeah.
Okay. So for this, I drew a diagram with two circles again, and then they're connected.
Yeah.
And then to the left, you have 2,000 newtons on the left circle, going backwards.
Yeah.
And then going down from that same, so from one is 1,600. That's the weight.
Okay.
And then forward on the right is 12,000 newtons. And then on 6,400 going backwards, it's Rn.
Yeah.
And then on the leftmost square, it's rectangle. It's 2,000 newtons.
Mhm.
And then we need to work out. And then we got the acceleration, and we need to work out r. So we use F equals ma.
Yep.
So you get Rn equals 6,400. Is that right? 6,400 times 0.5.
Say it again.
Rn equals 6,400 times 0.5.
Don't forget the 12,000. So 12,000.
Would it be 12,000 plus Rn? Or minus Rn, sorry.
Yeah, forget the n. N is
Okay.
just it's like centimeters. 12,000 minus r equals
Okay.
6,400 times 0.5.
Okay, and you get 12,000 minus r equals 3,200. And then you minus 12,000 on both sides. You get minus r equals minus 8,800. Then you times by minus 1 on both sides. You get r equals 8,800.
Sure hope so. 8,800. No. Let's see. Felt weird. What's wrong here? So the train is 6,400. It's pulling a car 1,600. Let me see. Yeah. Don't know why that didn't work. 12,000 minus r is equal to 6,500 times the acceleration. Let's do it. Let's take the entire system into account.
Okay. So we have so altogether, so we have 12,000 minus 200 minus r. So not 200, 2,000, sorry.
Yeah.
Minus r equals 8,000 times 0.5. And you'd get 10,000 minus r equals 4,000. And then you'd get minus r equals minus 6,000.
Right.
And then you'd times by 0.1 on both sides. That's at 1, minus 1, sorry. So r is 6,000, right?
Is that what you got? 6,000?
Yeah.
So we got two different answers. That's weird. R is 6,000 newtons. And that one's correct. I wonder why. That's why. We forgot about tension.
Mm-hmm.
So in our first one, it's 12,000 minus R minus T. That's why we can't do it just by itself.
Okay.
Yeah. Okay. And then how can we do B?
Okay. So for this, we only need to use the engine, right?
Yep.
So do 12,000 minus 6,000, because that's R, minus T, equals mass, which is 6,400, times acceleration, which is 0.5. And you'd get 6,000 minus T equals 3,200.
Mm-hmm.
And then you'd minus 6,000 on both sides.
You'll be fine for us, I think.
Yeah.
You'll get 2,800. Yeah, T is... They gave you the answer anyway. 2,800. And once it's a linear equation, calculator can do the rest, and you don't get any extra stuff. So I want to take a look. So this is connected particles. They're connected. You take the whole system. We found acceleration. Then we found tension. This one we were given acceleration, and we had to find a resistive force. Right? Let me just take a look at this. It's worth a lorry of mass towing a trailer. The lorry and trailer connected like an extensible bar. Driving force. The lorry and trailer. I think you'll be okay for this one.
Yeah.
So the part C interests me. When the lorry and trailer are moving at A. Okay, so let me just... Oops. So K is 7,200. And then the tension is 44,100. Okay, let's do question C.
Okay. So for this, we could use SVAT.
Yep.
Okay. So we know that it's moving at a... Wait. So we know that initial velocity is 8, final velocity is 0. We want to work out S, which is S. And we also have 4.5 as acceleration.
We did, but there's no way. Its acceleration is decreasing, and it will decrease down to 0. In fact, the decrease will become negative if it's slowing down.
Okay. So is it minus 4.5?
No. It's like, who knows?
Oh, okay.
Like it was going at 4.5, but then the thing broke, and so it's like slowing down, and eventually.
Okay.
So let's see. So that's 8. That's 0. That's S. What else can we get? Time? No. S U V A. Maybe we can get. Can we find acceleration?
Yes, we can. Using F equals ma.
Okay.
So you do force, would it be 7,200? No, 7,000, it's 72,000.
So I did this the quick way. I just want to make sure. When the lorry and trailer are moving, the tow bar brakes. The driving force on the lorry. So we're referring to the lorry part. So the lorry is at the front. The lorry, so that's 72,000, yeah.
Okay. $72,000, and then is it minus 2K, which is 2. Would you need to minus the resistances?
Yeah, minus 2k, and k was 7,200.
Yeah.
So that'd be 14,600.
And also 3K.
I believe 3k was on the trailer.
Oh, okay.
Yeah, if we drew a diagram, it'd be obvious. Okay.
Okay. Okay. And then you do mass, which is 3,000. Times A. You don't know what A is.
That's it.
So first you work out the bracket, so you'd get 7,000, 72,000 minus 14,400 equals 3,000. A.
I see a linear equation.
Oh yeah, linear equation, isn't it?
Wait.
I got 19.2.
How can it be positive though if it's slowing down? Or is it slowing down? Alright. A is 19.2.
Okay.
So then this will be v squared equals u squared plus 2as. I think.
Okay. So it'd be 0 squared equals 8 squared plus 2 times 19.2 s.
Mm-hmm.
And then you do. Okay. So I got 0 equals 64 plus 38.4 s.
Yeah, you love working out. Just calculator. That's all I do. Once it's a linear equation, it's all the same. But if you insist.
I got minus 1.67.
So the distance minus 1.67, and so maybe it's like 1.67 meters. Something feels very wrong about this though. 7.41. Yeah. Let me see this. I don't like this at all. Don't like that. I don't have a worked out thing. Let me just see. So you have a lorry. Its mass is 3,000. It's towing a trailer. Its mass is 5,000. Along a straight horizontal road. Lorry and trailer connected by a light and extensible tow bar. The lorry exerts a driving force. 72,000. Causing the lorry and trailer to accelerate at that speed. Sorry, the lorry and trailer experience resistances. So it's got 2k going against it.
Yeah.
The other one's 3k. Okay, so k was 7,200. So that becomes 14,400. Yeah, that makes sense. So what did we? No. Hold on. 72,000. Yeah. Okay. Find the value of K. We got it. Find the tension in the tow bar. But then the lorry and trailer are moving at the tow bar breaks, meaning there will be no tension in the tow bar anymore. Am I crazy? Wait, let me see. 44,100. So the tension in the tow bar was 44,100. 44,100. Okay, but I assume that would go away once it breaks. Why would there be any tension? No, the tow bar breaks. There's no tow bar anymore. Assuming that the driving force on the lorry and the resistance to motion are unchanged. Find the distance traveled by the trailer before it comes to rest. But it's moving to the right 72,000. It's moving to the left 14,400. This is a dumb hang on. We're dumbasses. What did we miss? That's what we missed. The trailer. Because of course the thing wouldn't come. The thing is still driving.
Not the what's it called? The lorry. We're looking at the trailer.
Yeah. Yeah, you know what? You have the method right. So
yep.
It would just be the working out would be same Suvat stuff, but for this one it would just be minus like 3k that thing equals 5000. Yeah. Okay, you know what we're doing. Okay, very similar. Acceleration, tension. Produce the force. The brakes produce magnitude. I think that's okay. Magnitude of the tension. Equal and opposite reaction. Okay. Right. Let's try this, and that's vertical.
Okay.
Sorry, I just want to underline that thing, trailer, to make sure I don't miss it again.
Yeah.
Okay.
So, do both particles have 180 being applied to them, or is it just all together?
So B is below A. 180 is, I think, like connected to A. So I think you have A, you have B, and then this is 180 newtons.
And then you have 10 kilograms going down for A and 5 kilograms going down for B.
Yeah.
Okay. Okay, so we need two F equals MA equations.
I think one is fine.
But once the magnitude, don't you need to do the square root squared thing added together?
Oh, you kids on your magnitude. I regret the day they ever put that in. Magnitude is just length. So, okay, the length of a diagonal line, you need to do Pythagoras, but this is just a straight up and down line.
Okay. So, F is 180 equals M, which is...
Hold on. You've got downward forces as well.
Oh, is it 180 minus 15g?
Correct. That's what I was waiting for. So that's 10g, that's 5g, yeah.
Equals mass, which is 15a. And then,
yeah.
And then you could do 180 minus... So 33 equals 15a. Then you divide by 15 on both sides. And you get 2.2 equals a.
Okay, and B?
Okay. Would this just be... would it just be 33 minus t?
How'd you get 33?
That was from doing 180 minus 10g minus 5g.
And what was it again?
33.
To find the tension in the string, you would have to isolate one particle.
Oh yeah. So you could use A, so you do 180 minus 10g minus t.
Yep.
Equals MA, which is 10g. No, 10, sorry. 10 times 2.2.
Yep, and you'd put in the calculator, get the answer.
Yeah.
I would use the simpler one, which is the other one, T minus 5g. It's only got two forces, equals, what was that one? 5 times 2.2. Although I kind of do prefer this one. Even though there's a lot more stuff going on, you can be quite certain of it.
Yeah.
Let's just see. So A was 2.2, and then T minus 5g equals 5 times 2.2, and the other one, so you get T is 60.
Yeah.
Say that, and so you get T equals 60 newtons. Okay, that's all right. Force of what is P in this one? Connected by a light. Find the value of P. Hang on. Two particles. I don't see any P.
Me neither.
Am I not seeing it? No, before I... What? Is this the right question? We have A, we have B. That one is 16G. That one's 9G. Going up is 250. Going up is 250. They're connected. Let me see this one. Is the acceleration B?
Maybe.
I don't know. I'm going to guess the acceleration is P. So how would you do part B?
Okay.
And the acceleration is 0.2.
So you do T minus 9g equals 9g. No, just 9 times P, which is 0.2.
Yeah, you need to get your answer.
Yeah.
That's great. Let me just ballpark this one. So that's 0.9, 1.8. 9, it's about 10, 90. Oh, I don't know. Oh no, 9. Yeah, that's about 10. No, so yeah, I think that P was supposed to be for acceleration. All right, now they're getting weird. Let's see this one. Raised vertically using the string. Force exerted on must be. Yeah, I suppose. Yep. Okay, it looks like same idea, except now you find the mass. I don't see it as being any more difficult. By letting practically historically. Aha. Is this the previous one? This magnitude. Find the magnitude of force P. No. Oops. Magnitude of force P. That looks very similar to me. Except now you're just finding the force. I don't see that as any more difficult. Okay, I was wrong. There was one more section. Silly me. Okay, pulleys. I have to figure this thing out. Okay, let's do this.
Okay.
Hang on. Give me a diagram, man. Yeah, give me a diagram. Okay, hang on. All right. Okay, how are we doing this one?
Okay. So, we know that P is 2m and Q is 3m.
Mm-hmm.
So one of the circles is 2m and one of them is 3m.
All right.
So an equation of motion, would it be two m minus 3m?
Let me see. So let's say F equals ma. So 2m minus, well, which way is it going? The 3m one.
Yeah, it'll be going down. Q would be going down and P would be going up.
So you have, okay. So it's like F equals ma.
Yeah.
F equals ma. So it would be the, I don't have a acceleration or anything.
Yeah.
Doesn't seem like you could use a Suvat one. V equals, no. Did you want F equals ma? Oh, okay. Hang on. C minus genome A. Okay. This is very vague. So what they're leaving it is like there's just a pulling force T. There's a downward force, which is 2mg. And so how could you make an equation with those? Can you hear me?
Oh, I can hear you now.
Okay.
Yeah.
So how could you make an equation there in terms of T and M?
Okay. Would it be F minus T?
I think it would be, so T is like it's being pulled up because the other one's heavier. So it'll be whatever that tension is, T minus 2mg.
Okay. Does that mean the other one will be T minus 3mg?
Let's take one at a time.
Okay.
So this one, T minus 2mg equals
2m. 2ma.
2ma. And how about the other one?
Would it be T plus 3mg?
This one is going, it's going to be going down, like clockwise.
Yeah.
And so it will be the other way around. The bigger force is 3mg. So it'll be 3mg minus T.
Okay. Equals 3ma.
Yeah. And B.
Okay. But how? Wait. Okay.
So what I'm thinking is you can like bring these two together by eliminating something.
See, could you solve it as simultaneous?
So I think there's 3 unknowns. So maybe if we made one, like if we subbed T for a different one. So in the first equation, you could write that as T equals 2ma plus 2mg. Let me think. Yeah, so I just want to keep this simple. So 3mg minus 3ma is equal to 2mg plus 2ma. So that's what you get when you bring those two together. But you've got two unknowns. You've got m and g. So I think we need another. I think what we've done is we isolated p, then we isolated q. Any idea what an equation would be for the whole system? That might be an additional equation, and then we could use that.
I have no idea.
I think it might be like F equals ma. It might be 3mg minus 2mg is equal to 5ma. So we've got 3mg going down. It's minus 2mg going up. And the total thing weighs 5m.
Okay.
And I think we could use that simultaneously with the one above it. How could we do that? Maybe simplify this.
But it would just be mg equals 5ma.
So mg equals 5ma. Oh, hello. Wait, yeah. So what can you do there?
Just divide by m.
Yeah.
So you get g equals 5a.
Yeah. And so a equals?
5g. Or 5 times 9.8.
A fifth.
The fifth. Okay.
Yeah, divided by 5. A fifth of g. So that's b. Okay, c.
Okay.
So we want tangent.
Okay. So that'll be, would you use F equals MA again?
Yep.
And we already know what A is. Okay, so.
Mm-hmm.
So F is 2mg. What is it, 2mg and 3mg? Oh, we only need to use one, don't we?
We might need both, but we'll see. Go on.
So could you just use 3mg minus T?
Yeah.
Equals 3m times A, which is what, a fifth G.
Mm-hmm.
Okay. So. I got tension is 23.42.
Okay. Let's see this. So, and did you get the mass? Did you get M?
No, I got T.
How did you get T without M?
Well, what I did was I did 3mg minus T equals 3m times the fifth G. That's the first part.
3mg minus T.
Yeah.
This one over here, is it?
Yeah.
Okay, equals
3m times the fifth G.
Yeah.
And then I worked out what a fifth of 9.8 was. So I got 3mg minus T equals 3m times 1.96.
Mm-hmm.
And then I got 3mg minus T equals 5.98 m.
Yeah. Okay.
And then I divided by m on both sides.
Then it would be T over M.
Oh, that's why I went wrong then.
So that would be T over M, but we need so this is what we still need M to do this question. This one here, if we so this is what we got when that was the whole system, is that right? No, that wasn't the whole system. That was what we got when we brought the two together, I think. So you've already done some of the work. So if you did a fifth G into this one, let's see. So 3m, I'll do times 9.8 minus 3m, a fifth of times 9.8 equals 2m, a fifth times 9.8 plus 2. Wait, that's just 9.8.
Okay.
So I'm just replacing all the G's with 9.8 and all the A's with a fifth.
Yeah.
Times 9.8. That now only has m, and so you could solve that to get m and then sub it into your one, and that would give you t.
Yeah.
That's sorry. So it was simultaneous equations essentially, because you had three things in total. You had t, m, and a. For part one, we found a, and then for this one, you would have to find m and t. Really,
Yeah.
I'm really not a fan of this question. Don't like this. Find the force exerted on the pulley by the string. Okay. Unfortunately, we'd have to find m for this one.
Yeah.
Okay.
I got x is 7.
Great. So the mass is 7. Come on. There we go. So the mass is 7. Okay. So how do we do D?
Okay. So do we need one of them, or do we need both of them?
So I think we'll need both. I think there's like overall, they're kind of pulling down on the pulley itself.
So you do 2mg plus 3mg.
Yeah.
Which is 2 times 7 times 9.8 plus 3 times 7 times 9.8.
Yeah. So I think it's just like 14g plus 21g. Yeah, so it's like 35g. So that'll be close to 350, I think.
Yeah.
Let me just take a look. They're still doing it in terms of m and stuff. This is crazy. It's terrible question. Find the distance moved by q in the first 4 seconds. All right, how do we do that?
So could you use Savat for this, or would it not work?
Yeah, see that.
Okay. So is initial velocity 0.
Mm-hmm.
T is 4.
Mm-hmm.
S is S. And is final velocity also 0?
No. Leaving only A. Which
A is a half G. A fifth G, sorry.
Yeah. A is a fifth G, and you'd use Suva for that.
Yeah.
That's great. And it'll be S equals UT plus half AT squared. Let me just see this one. S equals ut plus half at squared. Yeah, 0, fifth g, 4. Great. And let me see. The pulley is smooth in your calculations. Okay. Okay, so let's see. So you take the two separately. Go from there. Let's see. Okay, pulley. Okay. Pulley stuff. Alright. Maybe we'll just maybe we'll just do one or two questions like this next time, but basically we're finished this. They're all the same. Yeah. What do you give yourself for that?
Probably a half. It's pretty difficult.
Yeah, that's a difficult one. Yeah, how was that for you, Adam?
That was good.
And so I think, yeah, definitely chapter. Let me just make sure. Yes, okay, it's definitely chapter 11 next time.
Yep.
Any questions for me in general?
You know that last question we did?
Yeah.
You know how like the way they answered it in the mark scheme was like M? Would you need to do that in the exam, or would they mark it correct if you just gave it as a whole number instead of M?
I think it's pretty crap question. I'd have to look it up, but it strikes me as particularly bad. Like an equation of motion for P, but you need to say in terms of T, M, and A. Like I was expecting an actual equation that can be solved. You also, I mean, why would you keep it as M? Every other question, you know, if you're given a simultaneous equation, you solve both of them. Like you can. I mean, mass is 7. It's not difficult.
Yeah.
You know, it was easier to find the mass than to find the other thing. So, I don't think it's a type. That's an example question. It's not like these, which are exam questions.
Yeah.
And so, I don't see it, but I'll look up the exam questions for it.
Okay.
Anything else?
No.
All right. Well done, Adam. You did great.
Thank you.
Have a nice weekend, and I'll talk to you next time.
You too.
Cheers.
Bye.
Take care. Bye bye.